Hello, everyone. So this time we're going to talk about anatomy and physiology again, hopefully onto some of the more interesting concepts. The first thing I want to talk about is about the integument. This is also known as the skin. So what is the integument or skin? Well, I shouldn't say it's skin because the integument also contains stuff like hair or nails and stuff like that. It's just whatever protects your body from the rest of the environment. So it has many protection, many functions. First of all, it serves as a barrier for immune functions and also against losing water, drying up, stuff like that. It also maintains thermal homeostasis. This is done through obviously ideas of sweating and all that. It's also a sense organ, which, well, because you can feel pain and you can feel hot, cold, and touch with your skin. And it's also for vitamin D and calcium homeostasis. So essentially, and when you're in the sun, you actually are able to absorb some form of calcium or vitamin D just to, just for your body and stuff. So integument contains the cutaneous membrane and accessory organs. The cutaneous membrane is what we would know as your skin. So let's say you have a flap of skin like so. Your skin part of the cutaneous membrane will be composed of this upper layer called the epidermis and the bottom layer called the dermis. And then you have accessory structures such as hairs, sweat glands, and whatnot. There's also the hypodermis, which is not part of the integument, which is just something we should have as key. You have two types of skins. One is hairy, and the second is non-hairy. And the key ideas is that on your palms, you would have non-hairy skin, but everywhere else in your skin, you would have hairy skin. Hairy skin is also known as thin skin, whereas non-hairy is known as thick skin. Sorry, I'm going to double check that. So hairy is equal to thin, and non-hairy is equal to thick. Yes. Because of this, well, the reason because of this is because if you look into your epidermis, this top layer here, if we just examine down here, I'm gonna see if you can see it here. It's separated by 7 layers. You'll find that this top layer has like 7 layers, like one, two, three, four, five, six, seven. Well, it's 6 layers, but the catch is that you're gonna have, wait, actually, it's gonna be 5 layers rather than six. So it's going to be stratum corneum, stratum lucidum, stratum granulosum, stratum spinosum, and stratum basale. So it's actually going to be five. So you have these 5 layers of skin of stratified squamous epithelium, but only in thick skin do you have lucidum. Stratum lucidum is different. What's interesting is that within these layers of the epidermis, the basal layer, the most bottom layer, have these sort of basal cells. And in the stratum basale in the stratum basale, one, two, three. Yeah, in the fifth layer here, stratum basale has basal cells. And then in stratum spinosum, they turn into keratinocytes, which keratinocytes create keratin. And then keratin is a tough water resistant protein, which resists insensible per perspiration. This means that it's basically able to resist your skin from drying out on itself as a protein. There's also melanocytes in the stratum basale. Let's say melanocytes, and they produce melanin that is converted into keratinocytes, and then this is shared around. So melanin is able to protect UV photons from damaging DNA. However, it also it releases the energy safely, but the issue is that it also prevents from too much from accurate, like ensuring vitamin D secretion or vitamin D absorption. So there's a trade-off there. Now there's also two layers of it. Now let's talk about dermis since we've already talked about the epidermis. Let's talk about it up here. So as for the dermis, you have, let's hopefully zoom in on this section. You have two layers. You have the papillary, papillary layer and the reticular layer. So the reticular layer is dense, whereas the papillary is loose connective tissue. And this is just a difference. So I think a good acronym is PR, like permanent resident, or anything. You can think of many sort of acronyms or just ways of remembering. But you just gotta remember the top one is loose and the bottom one is dense. And there's also accessory structures such as sensory neurons, hairs and whatnot, sweat glands, and all that sort of jazz. There's also a lot of pain and touch receptors. For example, lamellar corpuscles, Merkel cells, and whatnot. You also have skin and you also have hair and nails and stuff. Let's say this is your finger. You have your nails, you also have hair going out of skin. These are all part of the integument. There's two glands that you should know. One is a sebaceous gland. This secretes sebum, and sebum is basically like oil. It's basically what gives you pimples and stuff like that. And what's important is this that this is able to protect from any bacteria entering, but also just have a little waxy layer on your body. And the other layer is sweat glands, and they secrete sweat. Now, sweat glands, there's something interesting. I'll just list it down here as a quick note. There's apocrine sweat glands. This is in pubic areas and axillary. This smells bad. And you also have eccrine glands, and this is found everywhere else, which don't smell as terrible. Another thing you should know is that the integument, like our parts of the skin, can repair itself. How does it repair itself? It has three phases or four phases. One is the inflammatory phase. This is where cells, let's say we have a site of injury like here, cells will come to recruit itself here, and this will start to have a little bit of bleeding. And then we have the migratory phase, where we start having the sort of formation of a scab. Well, the first thing we need to know is that in the migratory phase, the epidermis has proliferation of basal cells. However, in the dermis, you would have recruitment, proliferation, differentiation. So essentially, you'd have a lot of fibroblasts, mesenchymal cells, and whatnot there. And because of this, after proliferation, yeah, the other two phases is proliferation, where the bottom part of the clot starts to dissolve, and then scarring, where there's scar formation. Well, it's because these two phases occur because in the proliferation phase, the epidermis has normal division of the cells. It just naturally heals up, looking the same as before. Whereas in the dermis, you have this sort of activated collagen secretion, and you can create scar tissue in the dermis. So you just have to remember, the dermis, the bottom layer, scars, but the epidermis does not scar. Um, so there's two ways your body can function in terms of thermal homeostasis with the integument. The first one is evaporative cooling. This is with essentially just sweat. The other one is radiant cooling. Radiant cooling is essentially basically stuff like changing your the smooth muscle in blood vessels. You can change, okay, I'm gonna just write change smooth muscle in blood vessels. And this is just leading to more heat loss. Your epidermis participates in creating calcium by synthesizing vitamin D. Basically, sunlight goes into your epidermis. Light goes into your epidermis, and this gets transformed into cholecalciferol, and cholecalciferol goes into your liver. You can also get cholecalciferol in your diet, calciferol. Well, cholecalciferol is another term for and vitamin D in your diet also goes to your liver, and then goes to your kidneys to be turned into calcitriol. And then the calcitriol acts onto your intestines of your digestive tract. And this basically, calcitriol helps with sort of vitamin D absorption, or sorry, calcium absorption. And yeah, there's also signs of aging, such as if you'll see in older people, you'll see people have lighter skin. That's because of less melanocytes. You have drier epidermises, thinner epidermises, decreased immune function, and reduced blood supply. So now let's talk about something that's another one. Talk about bones, limbs, joints, and tendons. This one is always fun. So the bones are work together to support the body's weight and allow it to move. Now, there's three things in terms of connective tissue in the skeletal system. Cartilage, which is a supportive connective tissue. Supportive. And you can think of cartilage as what makes up your ear, your nose, and whatnot. So it's kind of like a hole in a way, like not like a hole, like you put something in a hole, but like it covers things consistently. And then you have ligaments. Ligaments are dense, regular connective tissue, and this anchors bone to bone. And again, you also have tendons, which is also dense, regular connective tissue. But tendons anchor bone to muscle. So there's a distinction there. Cartilage and bone are similar, but cartilage is made out of proteoglycans and are more flexible, whereas bone is made out of collagen, calcified, calcified. Now let's talk about cartilage. We actually have three types of cartilage. All of them have proteoglycans, but we have hyaline cartilage, which is composed entirely of uh, proteoglycans. You also have elastic cartilage, which contains elastin, and you have fibrocartilage, which contains a lot of collagen. Bones, there's also two types. One is compact, and they're more resistant to damage. Like if you look at a bone actually on its own, you'll see that this part's going to be empty. The compact's going to be this side, where it's going to be very hard and stiff. And then you also have spongy bone. Spongy bone is, as it says, spongy. It distributes force and is light. The spaces inside the bone are filled with bone marrow, yellow and what's it called? Yellow and red bone marrow. There's such things. There's four types of cells within bone tissue. Uh, the most important are these two pair, osteoblasts and osteoclasts. Osteoblasts and osteoclasts, they build up and also destroy the bone, dissolve the bone matrix. Blasts build up, while clasts destroy. There's osteogenic cells. They produce more bone cells, and also osteocytes that just maintain the bone matrix. Now, cartilage can grow through two different methods. Now, you might be wondering why cartilage is related to bone, but I'll explain in a bit. Cartilage can grow through two different methods. One is interstitial growth, and that's through proliferation. And proliferation means cell division. This one turns into two, what two turns into three. And then appositional growth. And then this is differentiation into new chondrocytes. So you have a stem cell that turns specifically into new chondrocytes and stuff there. But in adulthood, you only get division by appositional growth and not by interstitial growth. Now, why might this be important? Well, bone grows through two mechanisms. Endochondral growth is related to the ossification of cartilage. So think about your bones when you're a child as being very soft and underdeveloped. So your bones are going to grow at the shaft here, and you're going to see a lot of interstitial growth of cartilage. So the bone is going to lengthen, like here. But in the end, when you hit puberty, your growth plates are going to start to ossify. This means that the cartilage at the end of your bones are going to turn into bone rather than becoming flexible cartilage that we see from interstitial growth. What happens then is that you're gonna stop growing essentially. However, appositional growth can still happen in adulthood, and appositional growth can occur through the sides of bone, and this is making the bones wider and thicker. How it does this is that let's imagine this is two pieces of bone. Osteoblasts build on the outside of the bone, whereas osteoclasts dissolve the inside of the bone. So this leads to just creating more and more layers. Now, one exception is actually dermal bone and sesamoid bone. They don't ossify from endochondral growth, or they don't ossify from hyaline cartilage. I should mention here, this is hyaline cartilage. They don't ossify, but like dermal bones are ossified within dermal tissue, whereas sesamoid bone form within tendons. So another thing we need to know is regarding joints. Bones connect to each other via joints. The most important joint we need to know is about the synovial joint. Synovial joints are kind of joints where you see the most amount of movement. The best example of a synovial joint is a ball and socket joint. You know your shoulder joint? That's going to be a synovial joint. It allows for the greatest range of motion. Now, what's important about synovial joints is that each of these synovial joints, they have something called the articular capsule. Imagine this is two pieces of bone here. They have an articular capsule. This articular capsule or synovial capsule, and this capsule has articular cartilage in between these two bones. Articular cartilage is a subtype. So I'm going to write this articular cartilage, the subtype of hyaline cartilage. But what's important about it is that while bone remains well, this lacks a peritoneum. Peritoneal layer, a peritoneal layer, not peritoneum. Because it has no peritoneum, or peritoneal layer, it's allowed to be very flexible, but also it can't repair itself. Now you can think about the implications of this. Bone healing heals very well. Bones also heal very well. I want to clarify. Uh, they first form a callus, an internal callus. They first form an from internal going to an external callus. And then this is the formation from spongy bone to compact bone. So let's say your you have a fracture here. Initially, it's going to just be a big mesh of things, and this is what we call a callus on the inside. And this is similar to the spongy bone we talk about. And then after, it turns into an external callus, or it turns into compact bone. In contrast, cartilage does not repair itself well. Because remember, we have no interstitial growth, we have to use appositional growth. So because appositional growth, uh, basically it doesn't heal as well because it's gonna be maturing into new chondrocytes. It's gonna be very weird. It's not gonna be the same cells that are before. One consequence is actually in cauliflower ears, where it produces dense connective tissue proper instead of elastic cartilage. This is one example. One example of a disease actually is that, remember when we talked about the articular cartilage and peritoneal layer? Osteoarthritis is a neurodegenerative disorder caused to the damage to the articular cartilage. And it's inflammation, more pressure, and more damage. And overall, this is just going to be what's on any sort of exam or anything for joints, whatever. Okay, let's move on to skeletal muscle. So, skeletal muscle. Remember how we talked about muscle being one of the four basic types of tissue? Now, there's also three subtypes of muscle tissue. You can have skeletal muscle tissue, cardiac muscle tissue. These fall into striated muscle. And this cardiac skeletal muscle moves the body, whereas cardiac muscle pumps through the blood. You can also have smooth muscle, and this is in it's just called smooth muscle. This is part of the digestive blood vessels, digestive tract, and many other places. So muscles are connected to the skeletal system via tendons, as we said before, and they're grouped within layers of fascia. Each muscle is actually an individual unit. So let's look at this, okay? Let's say we have a muscle unit here. The muscle is surrounded by an epimysium. And then you can see a bunch of little threads, little balls of muscle here, little bulk balls of muscle. So let's just take one of these out. So one of these units is surrounded by what we call a perimysium. So within a perimysium, this is what we call a fascia. One fascicle, sorry, fascicle. This is a muscle. This is a fascicle. And then within the perimysium of the fascicle, we have these little muscle fibers. And these muscle fibers are surrounded by an endomysium. Endomysium. And then within the endomysium, within these fibers, sorry, muscle fibers, the muscle fibers, we call them a myofiber. And inside of them, we have a myofibril. This is like very small, myofibril. And within the myofibers, we also have something called satellite cells. These are stem cells, or I'm going to label these. Well, myosatellite cells. Myosatellite cells. These are stem cells for each muscle tissue. You'll also find probably some neurons, some endothelium and stuff. But the main idea is that we have this organization from muscle to fascicle to myofiber and myofibril. And you also have this sort of connective layer tissue from epimysium, perimysium, and endomysium. And you don't have anything here for the myofibrils. They're as small as possible. One thing interesting about muscle is that one of these myofibers have a lot of nuclei that stretch around them. And these myofibers are produced via fusion of myoblasts. This is during development and can be repaired in an adult through myosatellite cells. And one thing is that each myofiber has only one neuromuscular junction. So as part of a motor unit. So what is a neuromuscular junction? So let's just zoom in onto this a bit more. So imagine we have this going here. We have a myofiber. We're gonna have an NMJ. Well, better yet, let's just draw it. This is a neuron, a motor neuron specifically. It attaches on into the MNJ onto a myofiber. And this basically is the sort of organization. This is called a motor unit compared to a motor neuron and motor. This is the myofiber, NMJ, and motor neuron combo is called a motor unit. However, a single motor neuron can have NMJs with a lot of other myofibers, like just like this. You can note that this one thing is a motor unit. You can think of it as the motor neuron is cheating, whereas the myofiber is loyal. The myofiber stays to the only motor neuron it has, but the motor neuron can attach to many myofibers. And then let's zoom into the NMJ, the neuromuscular junction. Inside this junction, we have the axon terminal. We have something called the synaptic cleft. And we also have these sort of things called motor end plates. Now we'll go over this a bit later. The cytoplasms of these myofibers contain specialized structures called containing myofibrils and whatnot. But there's a very complex organization of these. That we'll talk about them later in a bit. But the biggest idea, let me just check what I have on my slides. We'll talk about them next, maybe later. But the organization is into these organized units called sarcomeres in myofibers. They're organized into these repeating units called sarcomeres. So this could be one myofiber. They're all in these square units that work together. And there's ideas of excitation and contraction. So first, excitation is when a signal is passed from the NMJ down onto the myofiber, and contraction is when they become shorter and produce a lot of tension. Ah, I want to see if I need to go that much in detail with this. Okay, I'll go in detail then. So let's talk about the stages of this contraction and whatnot, the myofibers. So the myofibers themselves, they are surrounded by something, they kind of look like this. So we have a myofibril, like here, and surrounding each myofibril, let's imagine it's like this, you'll have this sort of something called a SR, sarcoplasmic reticulum. So the sarcoplasmic reticulum, they hold onto a lot of calcium. And then you also have these sort of T-tubules that line up each one of these SRs. And these release calcium out. You also have a sarcolemma and sarcoplasm. And yeah, so why is calcium so important, you may ask, is because it relates to the excitation and contraction. So remember how we talked about the NMJ, how we have the motor neuron, the NMJ here. So what happens at the NMJ is that when you get the electrical signal down here from the motor neuron, it excites the NMJ. So excite NMJ is step 2. And then this propagates the electrical signal around. So when it's excited, the motor neurons release a chemical neurotransmitter, while the neural neurons from up here releases a neurotransmitter called acetylcholine. We can call this ACH for short. And acetylcholine is basically released from the neuromuscular junction, from the NMJ, released acetylcholine. And then acetylcholine binds to acetylcholine receptors onto the motor end plate or the synaptic cleft. So ACH to ACHR onto synaptic cleft. And yeah, this also there's also this allows to spread the excitation alongside the muscle. There's also enzymes that remove neurotransmitters such as acetylcholine, but I think that's too much information for now. But excitation spreads due to the release of voltage-gated ion channels. Near the neuromuscular junction, the excitation spreads around the sort of channels created through the sarcolemma, and this leads to an action potential. This action potential propagates. So T-tubules bring this action potential that's propagated by acetylcholine towards the vicinity. T-tubules bring AP to the SR. So imagine here, it brings the action potential to the SR. And this SR, by bringing it close to it, this triggers calcium release. And then calcium release basically reveals the binding site of the muscles, and that creates contraction. I'll explain a bit more in depth, but basically the excitation of the muscle cell begins at the NMJ and then spreads through the muscle fiber. So yeah, let's see. I'm gonna just stop it for now for today, but I hope you guys have learned something, and yeah, I'm just gonna go over all of anatomy and physiology as I can. Thank you.